Welcome back. Problem 3.34. So a shear spring is made from two blocks of rubber, each having height h and width b, and thickness a. The blocks are bonded to three plates as shown. If plates are rigid and shear modulus of rubber is g, determine the displacement of plate A if vertical load P is applied to this plate. Assume that displacement is so small delta is equal to A tangent of gamma, which is equal to A into gamma. So from here you can see these are the two aluminum, these are two blocks rubber, and that is connected to these three plates. Clear? And a load P is applied at this point. So due to this load, this spring will bend like this. So you can see, so what you have to do is you have to find this deflection delta. So we will solve this problem. I hope you have a clear understanding about this problem. So what we have to find is this small deflection delta. So let's start with this solution. Again, you can see that this is the plate, so this force P is applied. So due to this, it will bend like this. So this P load will be divided by 2. The shear force on each side of this this plate will be P by 2, and again this will be P by 2, which is equal to P. So if you take this rubber, if we take rubber block and analyze it. So let me draw this rubber block. So let's say this is your rubber block. Clear? This is your rubber block and this is its width b, and this is its height h. So this is the height of rubber block. Clear? This is its thickness a, and this is its width b. Clear? So the load that will act on this side, which is, I will draw it as dotted line. So the load at this side will be equal to P by 2. Clear? So you can also represent them over here. This will be P by 2. And due to, if I draw it over here like this, so due to the load, so this will, there will be a deformation. Let this deformation will be like this. Rubber block will bend like this. Clear? So we have to find this deformation, this deflection. This is delta. Clear? And let this angle due to the shear deformation is gamma. And the load on this side is again P by 2. Now we can apply, and this P by 2 is equal, P by 2 will be equal to this shear force V. Now we will know that average shear stress, V is equal to P by 2. And we also know that shearing stress is equal to V shear force divided by shearing area. So shearing force is P divided by 2. And what is shearing area? So you can see the shear force is applied on this face. So this face will having breadth B and height h will be the shearing area. So we will write that shearing area will be equal to B into H. Now from Hooke's law, we know that shearing stress is equal to modulus of rigidity into shearing strain. So we have this shearing strain will be equal to shearing stress divided by modulus of rigidity. So you have the shearing stress this, so it will be equal to P divided by 2G into B into H. So you have this shearing, this will be your shearing strain. Okay, as you can see that this is A, this is gamma, and this is the deflection which you are interested to find out gamma. And from our equation, S is equal to R theta. So here S is equal to this delta. So delta is equal to R is A, and theta is equal to gamma. So we will use this equation. So what we have to do is that this is not R, this is gamma, shear strain. So I will write it, this deflection is equal to A into gamma. So you can put the value of gamma, and gamma is equal to P divided by 2G B into H, that is equal to deflection. And this is our required answer, which is to be find out, and we have find out that. You can see we have to find delta is equal to A gamma, and from this we know that delta is equal to AP divided by 2GB into H, where P is the load, G is modulus of rigidity, B is the breadth or width of this rubber band, and H is the height. So this was a very simple problem. I hope you have enjoyed this video, and again, if you are new to my channel, then subscribe it and also share it in your community. Thank you for watching my videos, and again, if you have any question, you can ask me in comment section.